Network physical connectivity is all about the mediums which we use to connect our devices. We're going to discuss cabling types, termination, how to make a cable, and fiber optics. Let's discuss cabling types. Although most of us use Cat5e in a star pattern in our modern office networks, there's many different options, old and new, that can be used to connect our computers. All of these different cabling types have unique speeds and limitations on how long you can make the cable run. At the end of each connection is a connector type, and these vary greatly and they're constantly changing. Coax cable is composed of two conductors. One of the conductors is an inner insulated conductor, and that's surrounded by another one. The second conductor is sometimes made of a metallic foil or a woven wire. It is very resistant to electromagnetic interference, which could be caused by an electrical external signal within the vicinity. There's several different types of cables when it comes to coax. One of those is RG59. It's typically used for short distance applications, such as carrying composite video between nearby devices. It's not appropriate for long distance applications because of signal attenuation, and it has an impedance of 75 ohms. RG6 is used by local cable companies, and they use that to connect individual homes to their network. Like RG59, RG6 has an impedance of 75 ohms. RG58 has loss characteristics and distance limitations similar to RG59. However, the impedance of RG58 is 50 ohms, and this type of coax was very popular with early 10-base-2 Ethernet networks. Impedance is how we measure cables as far as their reliability goes. It refers to the amount of resistance compared to the flow of electrical energy. A 50 ohm cable will give us a better result than a 75 ohm cable. The RG58 gives us the 50 ohms and the other two cables gives us the 75 ohm. However, most installers are going to use the RG59 and the RG6 because they're already installed in network offices. The BNC connector was typically used for connecting network interface cards, and the F connector is now used for cable TV connections. Twisted pair is the most popular cable type today. Most of us use this type of cable in our computers to connect to a local area network. The reason that we twist the wires is to help with attenuation, also known as signal loss, and the ability to fight off electromagnetic interference, or EMI. And they come in two different types. The first one is the unshielded twisted pair, and the other one is the shielded one. Unshielded is more popular because it costs about half as much as shielded, and it works fine in most environments. Shielded is going to need to be added to networks that have a significant amount of possible EMI, such as in an elevator shaft or if you're working near high voltage machinery. Another addition you can add to your twisted pair cable is the plenum option. Plenum doesn't actually make cables work any better. They just add additional costs to both UTP or STP, but are required in certain types and sizes of buildings. So if you have a fire, you're going to want to have plenum cables because the toxic plastic as it's melting in the non-plenum cables can actually be very hazardous to your health. Let's take a look at the various different twisted pair categories. Now, it's really important for the Network Plus test that you know the maximum length and speed of each category cable. Category 3 had a maximum speed of 10 megabits per second, and it had a range of approximately 300 feet. Sometimes they measure this in meters, and so they'll say 100 to 125 meters. Then we had the Cat 4 cable, which had a max speed of 16 megabits per second, and it had the same range. Cat 5 also had the same range. We typically ran this at 100 megabits per second, but it does have a capability of 155 megabits. If you had a switch that was capable of gigabit speed, then you could get faster than the 100 megabit switches. Then we had Cat 5e, and this one is the most popular today because it still allows you to have the flexibility, that is, the cable is very flexible, that Cat 5, 4, and 3 have, but it gives you max speeds up to 1 gigabit per second, and the range is also 300 feet. On a practical level, separate from the test, you rarely are going to see this actually run at a gigabit, if ever. Typically, speeds run between 4 and 800 megabits per second with Cat 5e. Cat 6 gave us 10 gigabits per second, and still the range was 300 feet. The main disadvantage to Cat 6, however, is that it's not very flexible. It uses an extra pair of twisted pair cables on the inside of it, and it makes it a lot more rigid, so many cablers just don't like to use it if you don't force them to. Cat 6a also had a max speed of 10 gigabits per second, and its range is 300 feet. However, it's a little bit more reliable than Cat 6. So they gave it a little bit of an upgrade. It doesn't make it any faster and it doesn't go any longer. However, it is more reliable to block EMI, more stable overall, and it operates at 750 megahertz instead of Cat 6, which operates at 2540 in the megahertz range. And it also supported twice as many frequencies as Cat 6. Now, there are Cat 7, 8, and 9. However, they're not going to be covered on the Network Plus test, so we'll continue to move on. But they do offer faster rates and additional reliability. Cable termination is the connection of the wire or fiber to a device, such as equipment, panels, or a wall outlet. And here's some of the different connectors. RJ45 is used for Ethernet connections, and we see the terminators that are at the end of the cable. So without the terminators, you just see twisted pair that had nothing to connect to. RJ11 is used for digital phones and is a skinnier type of connection. Termination is used in telecom, data communications, and fiber optics. It involves organizing the cables and putting an end to them, and it creates a connection with a copper or fiber conductor. We see DB9 serial cables as well, and those are used for certain printers and modems. Not as used today as it was in the past. Most servers will still have a DB9 serial connection on them, but most desktops will no longer have those. Here are some additional looks for your cables. In this case, we see fiber cables, and we see a patch panel where we're connecting cables together. Cable termination is all about giving an end to the cable run. We don't want to have cables running directly from our computers through the wall into the switch. And that's because if we have any type of breakage along the way, then we have no way of reconnecting the computer without rerunning the cable. So if we have our cables terminated at a wall outlet, and then from the wall to another wall outlet in the server room, and then from there we create another termination from that connection in the patch panel into our switch. We have 3 different ways of terminating that cable run, and that gives us a lot of ability for replacing a cable without having to redo the entire run. Making a cable is going to be very important to our Network Plus test, so let's see how that's done. We'll start with the pinouts on the cable. We have a TIA/EIA 568, then we have the 568B, which we'll show graphically in a minute. We can make 2 different types of cables, a straight-through cable or a crossover. Now, we no longer really need the crossover cables in most situations anymore. The way this would work is if you're going to connect a computer into a switch, you would use a straight-through cable. However, if you were going to connect a switch to a switch, you would typically use a crossover cable. And that would give us the 568B connection you see above. So a straight through would be 568, and the crossover would be 568B. And all this refers to on the 568B is one of the pairs gets crossed over into a different pair. So it's a slightly different look when you create the cable. The reason we no longer need them is because switches automatically cross over for you now instead of having to use a crossover cable. And here's our all-important cable wiring. You're definitely going to need to memorize this. We see the 568A, which is a straight-through cable. And it starts with the green stripe. So anytime you see the breaks in the lines, you know that's a stripe. So in this case, it's green and white, etc. on the far left. Followed by a solid green, followed by the orange and white cable, followed by the blue, and then the blue and white striped cable. So you're going to see this all throughout here. Now take a look at the difference between the 568A and 568B. It's very subtle. First off, the solid green and solid orange cables are reversed. And we also see that the green striped cable has a new position as well as the orange striped cable. So when we take these wires on a shielded or unshielded twisted pair and put them into the terminator, you just need to make sure that these cable colors are lined up the way you see them. So for a straight through on both ends, you're going to have the 568A set up. And on the 568B, you're going to have this particular color setup with one of the pairs crossed over. Fiber optics gives us options that we don't have with twisted pair, such as no EMI, as well as much longer runs. An alternative to copper cabling is the fiber optic cabling, and that sends light signals through an optical fiber, and it's typically made of glass, but sometimes it can be made of plastic. And it's immune to any type of EMI. Also, fiber optic cables typically have greater range than copper and greater data carrying capacity. Fiber optic cables are generally classified according to their diameter, and they fall into one of two categories. First, you have the multimode fiber, and second, you have the single mode fiber. The wavelengths of light that vary between these two different types of cables is how things are measured. Usually, wavelengths of light in an MMF cable are in the range of 850 to 1300 nanometers. Conversely, the wavelengths of light in an SMF cable, or single mode fiber cable, are usually in the range of 1310 to 1550 nanometers. Multimode fiber optic cable has a larger core that allows multiple modes of light to send through data. Because of this, the number of light reflections created as the light passes through the core increases, and that creates the ability for more data to pass through at a given time. However, because of this high dispersion and attenuation with this type of fiber, the quality of the signal is reduced over long distances. This application is typically used for short distance because of that. Data and audio-video applications in local area networks, such as the way cable companies use them, cannot be transmitted over multimode fiber. So basically, you're going to find this type of connection in server rooms where we connect one switch from another. But it's not going to be in a long cable run from one building to another. For that, you're going to use single mode fiber. Single mode fiber has a small core that only allows one mode of light to propagate. Because of this, the number of light reflections created as it passes through decreases, lowering attenuation, and it creates the ability for the signal to travel much further. In this case, it could go for miles. The application is typically used in long distances and higher bandwidth runs by telecommunications companies, cable companies, and colleges and universities. There is a higher cost to single mode due to very exacting tolerances. Let's look at some of the fiber optic connectors. There is the straight tip connector, and it's sometimes referred to as a bayonet connector because of the long tip extending off from the connector. These are typically used with multi-mode fiber connections. We then have the SC or standard connector. It's sometimes referred to as a subscriber connector depending on what document you're reading, also referred to as a square connector. And the SC connector is connected by pushing the connector into the terminating device, and it can be removed by just pulling it out. An MTRJ connector, which stands for Media Termination Recommended Jack, is used by two fiber strands. One is a transmit and one is a receive. And a Lucent connector connects a terminating device in the same way by pressing them together or pulling them apart. And it was developed by Lucent Technologies. One thing to consider when you're setting up all these different types of connections, whether it's fiber or copper, is going to be the speed and duplex. You can set the speed to the maximum that your device can handle on a manual basis, or you can set it to auto-negotiate and let the switch or router you're plugged into to set it. Whichever way you set it, the device you plug into must match, or there's going to be packet errors. For instance, if you set your network connection on your computer to auto, then it should also be set to auto on the port you connect to on a switch. If you set it to 1 gigabit, it needs to also be manually set to 1 gigabit on the switch. If one's set to auto and the other one's set to something static, then you're going to have a lot of problems, speed issues, and packets dropped. When we transmit data, there's also some options. The first option is the simplex, or one direction. Signals can only be passed in one direction. Then you have half duplex, which means that signals can be passed in either direction, just not at the same time. And that's followed by full duplex, and this is the way that just about all networks are set up. Full duplex means that the signals can be passed in either direction and simultaneously. The only reason you would want to use half or simplex is if you have a really old device that's just not capable of full duplex, but everything made within the last 10 to 15 years is set up with full duplex capability. We covered cabling types and cable termination. We also talked about the very important ways of making a cable, as well as the different colors that you get with straight through and crossover cables when making a twisted pair cable and terminating it. And then we covered different fiber optic types, as well as the termination for them. Cabling is also going to be a very important part of our Network Plus test, so be sure that you understand the different concepts that were covered.